Hey everyone, I wanted to touch on a couple of things real quick with you before I go into the next video. First is I get a lot of comments about the rocket mass heater and mainly about the materials that I'm using in it. I actually choose to use some of the steel in here mainly to keep the cost down, and it allows me to do a lot of experiments with this. I'm well aware that the steel is going to wear out relatively quickly, but since it's so cheap, it just makes it easy to use it. Next is the questions about fresh air intake. A lot of people say I should have a fresh air intake on this. This is in a greenhouse, so that there's plenty of air just leaking in through various areas of the building. And also I like to help reduce the amount of humidity in the building by just pulling the humid air out of the building and into the rocket mass heater. So usually for the first hour or so I'll see a lot of condensate coming out of the exhaust, and it helps a lot reducing the humidity in the building. Lastly, I've had several people say that I should vent some of the CO2 exhaust directly into the greenhouse to help out the plants. This is just something that I'm not willing to do. It's a safety concern, and it's better off just venting the exhaust directly out to the outside. Thanks a lot, and I hope you enjoy the work that I've done on the rocket mass heater. Near the end of the heating season last year, I decided to rebuild the burn tunnel and heat riser. The antique clay bricks had mostly fractured, so I replaced it all with fire brick. This time I wanted to slow down the burn a bit and decided to go from an 8-inch heat riser to a 6-inch. Since I didn't want to weld up a new grate for the pellets, I left the fuel supply area wider and then tapered the burn tunnel down to fit a 6-inch chimney. This year I wanted a heat riser that would last a bit longer. I decided to use a section of 304 stainless steel pipe for the inner area and regular 10-inch galvanized stove pipe for the outer area, with rock wool as the insulation. Jumping through almost the entire heating season, I've burned with the setup for around 700 hours. The pellet grate has had enough. The steel frame wore away in the hottest burn area, but the stainless steel grate has survived, barely. I was surprised that the tabs that I welded onto the ends with my regular MIG welder survived, and only a couple had broken off. I'm also a bit surprised the grate didn't fall apart sooner, since the rear holder for the slats was completely missing. The failure of the grate came at a bad time, since the temperature was around 3 degrees, so I had to scramble to make up a new one. Luckily, I still had some stainless steel left over for the slat, so I had to make the frame out of regular carbon steel. This version has a couple of slight differences based on some observations over the winter. The previous design worked well, but I noticed a small few issues with it. The first change I made was to remove the back wall that supported the grate and added a bar for it to rest on. This allows for some more airflow behind the grate and also lets me see what's happening in this area. The grate got lowered into the ash pit a bit more so that the heat doesn't have to work downward as hard. The front gap on the grate remained, as it still aids with allowing some additional fresh air into the burn tunnel. It's handy to have, since I can pull any remaining ash out of the burn tunnel and drop it through this spot into the ash pit. I also lengthened the grate by an extra inch for more burning surface area. The slat spacing was widened to be just a hair narrower than the pellet diameter. The previous grate was a bit too thin, and occasionally the ash would build up if it burned for several hours. Instead of welding legs onto every other slat, I only put on 2. I bent the top screen down to keep the pellets from sliding off the end of the grate, and the legs are used to hold the screen in place. With the previous version, the screen above the pellets worked well, but the pellets were too thick, restricting some of the airflow through them. I lowered this screen so there can be more airflow going through the pellets. This allows them to burn faster, creating more movement of pellets over the grate, which helps to break up the ash and prevent clogging. The system is easy to load with pellets and can start right up. It certainly helps to give it a squirt of diesel to move things along. After a few minutes, it's up and running at full speed. When I had switched from an 8-inch to 6-inch chimney, I went from burning 12 pounds an hour to 8 pounds, thinking that it was the chimney size that reduced the burn rate. However, with my latest modifications, I'm back up to 12 pounds an hour. The stainless steel cover typically glows orange, and I usually can see the top of the barrel glowing. That's with the fan blowing to help circulate the heat. Here's a view from under the grate where you can see all the pellets are glowing and some pieces are falling through. With the increased burn rate and temperatures, I'm starting to find flakes of stainless steel from the heat riser. With my sophisticated imaging system, I probed inside the heater to see what was happening. The fire brick on the roof of the burn tunnel is in perfect condition, with a few flakes of ash stuck to it. But once we can see inside the heat riser, it's very clear that the stainless piping is buckling and won't last much longer. That's all the footage I have for now. Make sure you subscribe to see the next update about the rocket mass heater. Thanks for watching.